This is our Algebra 2 Unit 1 test preview. And this test is going to be over these topics that we're going to cover most of here in this preview. Domain arranged in inequality set and interval notation in behavior, restricted domains, maybe not so much restricted domains, but writing a linear function relating an amount over time. I don't think we're going to be doing this one here. Increasing, decreasing intervals on graphs, intervals where graphs are positive or negative, finding intervals of positive and negative values from set notation information. I don't think we'll do that one either. Graphical transformations, a little bit maybe, finding inverse functions, relations from graphs, tables, and equations, solving and graphing inequalities, equations, yeah. So I just kind of wrote that wrong. But anyway, we're going to cover these items. What is the range of the relation shown in the table? Okay, well the range, this range is going to be what? X or Y values. Well, it's going to be, range is going to be the Y value. So if you have like domain, I like to do domain, and then range. So we're going to be looking for the Y values here. And we're not looking for an interval. Now, if you wrote y is greater than or equal to 2, but less than or equal to 17, this would be absolutely wrong because we're talking about individual values. So the range is going to be represented by y equals, and the easiest way to do this is in set notation. To put 2, 7, individual, discrete data, 10. And I'm thinking on your test, you're going to have maybe a multiple choice opportunity to consider. So that would be it. And yeah, you could do it in interval notation too, but their interval notation is very clumsy. It's this business here. It's going to be 2, 2, and comma or union, 7, 7. Okay, so and so on. So in this instance, your set notation is going to be an easier way to describe that. Similar type problem, what is the domain of the relation shown in the table? Well, it's going to be domain, it's going to be x equals, same type of thing here, 1, 2, 4, 6, 7. All right, next. What are correct representations of the intervals shown on the number line? I think this might be a multiple choice problem on your actual test, but our critical values here are going to be what are going to be at the end of the interval. So we'll say x is equal to -3 is going to be one of our key values, and on the right side we're going to have x equals 4. So we could look at this as an interval. In interval notation, we would be, I'll say, interval notation. We're going to have greater than or equal to x greater than or equal to -3, and then continues all the way up to x equals 4. But is this going to be on the right side a bracket or parentheses? Well, that's an open point there, so we're going to have, this will be our interval notation. And inequality notation, we're going to have x is greater than or equal to -3, but less than 4. And finally, set notation. Really, set notation to me is easier after you consider interval notation because it's very similar. So we're going to have x such that x is greater than or equal to -3 but less than 4. So that would be our set notation. So be ready for any and all of these notations. Jacob earns $20 each week for his allowance plus $30 for each swimming pool he services. He wants to earn at least $150 each week. Write an inequality to represent the situation. So you have to look and see which one is better. Well, first of all, we want to earn at least $150 each week. So whatever this is, it's going to have to be greater than or equal to 150. Okay, so we already know $150. So what is 20 each week for his allowance? So for every week, so for each week, $20 each week. So that's going to be a fixed amount here. Plus, we're earning $30 for each swimming pool service. So we'll say X equals each pool service session. So we can say this will be 30x. So this will be an example of an inequality that would meet the situation. And so you could actually solve for how many pool services you need by subtracting 20 and then dividing by 30. So this will be an answer for this. So on your exam, you're going to be asked to create a similar inequality. Next, find the inverse of f of x equals 5x minus 3. Well, we already talked about the four-step process, step one of which is taking that f of x and changing it to y. So we have y equals 5x minus 3. Next step is going to be switch x and y. So we're going to rewrite this as x equals 5y minus 3. Third step is going to be solving for y. So I'm going to take 5y minus 3 and put that over on the left side and set that equal to x. And then we're just going to solve for y plus 3. So we have 5y equals x plus 3. Then we're going to divide both sides of this equation by 5. So we have y equals 1/5 x plus 3/5. And the last thing we're going to do is we're going to write our interval notation, our inverse notation, f negative 1 of x is equal to 1/5 x plus 3/5. And the last thing I'm going to do is show graphically that these are inverses of each other. And we get our calculator for that. And we're going to put in 5x minus 3. So here we have our TI-84C calculator, minus 3. And we graph that function. That's what it looks like. And we are going to, when we have an inverse function, reflect about the line y equals x. I'm going to make that a magenta here. So we graph that. So our correct answer, the one we put, is going to look something like this. And reflect about This is going to come like this, something like this. So where I'm moving the cursor now, just like this. This y-intercept here is going to be the x-intercept over here. This x-intercept here is going to be the y-intercept over here. Okay, go back for remembrance's sake. We're going to have 1/5 x plus 3/5. That should be our inverse function. So go here and go ahead and make this red. Alpha y equals, okay, we have 1/5. And I hope that you remember that that would be the same as 0.2x plus 3/5. I'm just going to go ahead and create a fraction, 3/5. Oops, didn't get that for some reason. 3/5, there we go. And see what that looks like. Yeah, see, reflect about this magenta line. If we really want to get it straightened out to get our proportionality exactly right, we can go to zoom square, and we go to zoom square. It's going to give us our proportionality that we can, I hope, better see the qualities that make these two functions represented by the red line and the blue line inverses of each other. They reflect about this magenta line y equals x. Okay, so this is going to be our correct answer. Next, refer to the graph below for next two problems. What is the domain and range of function in interval notation? Well, here it looks like we have some kind of polynomial looking function, and it looks like we are coming from negative infinity toward infinity. So we're going to say our domain in this case is going to be greater than negative infinity to less than infinity. Okay. And for our range, we have an unbounded function. So our range is going to be the same in this case as our domain. So that would be the answer to this problem. And we're going to use, it says use this graph for the next two problems. So let's see what this next one is. Describe the end behavior of the function. Well, that is very much related to what we have over here in our domain and range. So we would say that in our class, as x approaches infinity, f of x, and you can put y also, we used f of x, also approaches infinity. And as x approaches negative infinity, so going the opposite direction, going toward the left, f of x approaches, represented by this arrow, negative infinity. So there they are. These are our answers for this one. Next, determine whether the following pairs of functions are inverses. I think in your test you're going to have 4 pairs to look at. But here you look at these and you can tell by graphing or just by seeing if they are the same thing. So if we take either one of these functions and find its inverse, we should get the other one. So if we take this first one and say, okay, y equals 4x, and then we change this to x equals 4y, and solve for y, we get y equals x over 4, which equals 1/4 x. Does that match this thing here? Yes, it does. So yes, I'll say yes, call it inverses. And for this second one, we want to find if f of x equals 2 minus 5x and g of x equals 5x minus 2 are inverses of each other. So we'll take this f of x first and make this y equals 2 minus 5x, and then change x and y situations. We have x equals 2 minus 5y, and then we subtract 2, so we have negative 5y equals x minus 2. Now we divide by negative 5. And just working to the right here, we're going to get y is equal to negative 1/5 x, and that's going to be minus divided by minus, it's going to be plus 2/5. Okay, are these things, does this thing here match this? No. No, in this second case, not inverses of each other. And you can also, to diagnose inverse functions, go back to your calculator, and just as we did up here for the earlier problem, diagnose that this way. So they would. So I guess let's see what they are. We have 2 minus 5x and 5x minus 2. So 2 minus 5x. And down here we can put 5x minus 2. And graph these things. Do these two things, the red and the blue, reflect about the line, this line length? No, because we would see them over here like this. Okay, next. Refer to the graph below for the next two problems. Identify the intervals where the graph is increasing. Well, the graph is increasing, and when you say where are you talking about? You're talking about x values. Where the x values where the graph is increasing. So we're increasing all the way from x equals negative infinity to 2. So increasing on the intervals, we will have negative infinity to x equals negative 2. And then also from x equals 2 to infinity and to infinity. So that would be where these functions, the graph function is increasing. Okay, now we're decreasing, not this being asked for, decreasing on the interval from negative 2 to 2. And increasing everywhere else is what the solution is boxed in. Okay, next one, identify the intervals where the graph is negative. Well, the graph is negative below the x-axis. So here's a piece where the graph is negative, and here's another piece. Everywhere else, the graph is equal to or greater than 0. So we will say f of x is less than 0 on negative infinity to less than negative 4, and also looks like that looks like a little greater than 0 maybe that's 1. That'd be maybe 0.3, 0.3, not that that's really crucial. 0.3 to maybe a little less than 4, maybe that's 3.8. Okay, so that's where f of x is less than 0 or negative. Next, the figure below refers to a transformation of y equals absolute value of x. What is the transformation? What is the equation represented in the graph? One thing we've talked about quite a bit is the standard form of an absolute value function is to be a times the absolute value of quantity x minus h plus k. And the vertex is going to be the coordinate pair h comma k. We've talked about this a lot. So to look at this graph, we look at several things. I guess the first thing I like to look at is the vertex. So we see this vertex here at the point, looks like -2, 1. So that means that in order for h to be -2, we're going to have f of x equals a times x minus, and h is -2. So minus -2 plus k, well k is 1, plus 1. And this simplifies to x minus -2 simplifies to x plus 2. We have plus 1. And the last thing we have to consider is the value of a. Well, if we look at our graph here, we're going up 1 over 1. Okay, up, or we can go up 2 over 2. So we have our m, our slope is going to be 1 over 1, which equals 1. And so therefore, the equation representing the graph is going to be 1, a equals 1, so I'm not going to write anything out front there. Absolute value of quantity x plus 2 plus 1. And I want you to go ahead and be able to graph that in your calculator as well. So to do that, clear, clear, clear. So we have absolute value, second, catalog, enter. So we have x plus 2. And we'll say plus 1. And we graph that. And we should see something quite similar. And what I invite the viewer to do is when you actually work up a problem, you can set the dimensions the same as the graph to see exactly. You can set your with lines or dots to really ferret this out. So go here, and I'm going to go to second format, and I'm going to go ahead and turn on the grid line. So now graph, so we see that, and the last thing I'm going to do is take the dimensions of the graph. So our x value from -6 to 6, our y value from -2 maybe to 4, or -2 to 6. So let's do that and see if it just looks the same. It should. Okay, what we do is we go to Window, and x min -6 to 6, and scaling by 1, y min -2 to 6. Okay, we've changed all the dimensions here. Press graph. Okay, now you just go over here and look at it. Does that look exactly the same as this? Yeah, it does. So this is exactly right. This will be our answer to that question here. What is write the range in set notation? Well, range, we're going to have y such that we are y is greater than or equal to our lowest value on here, which is 1, but less than infinity. Also, you could alternatively write this as, I'll put a comma, y such that y is greater than or equal to 1. So that would be another possibility in set notation. Okay, graph the solutions to absolute value of x minus 2 equals 3. Again, you got a calculator you can use. This absolute value of x, I will show you a way to do that. If you take your absolute value parent function, which is going to look like this, I'm drawing it sort of freehand here. Great, okay. And then we come over here to the right like this. I'm doing this for a reason that you shall soon see. Okay, I tried to make sure I got all the corners. Obviously, the line is not terribly straight. But what translation do we have here? Well, we're going down 2. So I'm going to take this graph here and put it down 2 like this. So that's what we do to translate it down. And you can do this in your calculator as well. Let's see here. It isn't perfect, but it'll look like this. I want to get it across the corners. Equals 3. And so we can go up to x equals 3 and just put that horizontal line, x equals 3, or y equals 3. And so our solutions are going to be found here at the points 5, 3. That'll be one solution represented here. And the other one on the left side is going to be negative 5, 3. And you can just test the values. If you plug in negative 5 here, you're going to get positive 5 minus 2 is 3. If you plus positive 5 in here, you'll get, so we say x is equal to, we can put this in set notation, negative 5, 5. And we found these solutions by graphing. Very easy, likewise to do in your calculator. Absolute value of x minus 2 is 3. So we can go here to our calculator. Absolute value of x minus 2, and set that equal to 3. And we can graph and see that, right? X equals negative 5, x equals positive 5. Very easy to do. And that's it. That's covers probably 80% or more of what's going to be on your upcoming test. Good luck, and thanks for viewing.